which is DC self excited DC generator, right? So as I already told, it is classified into DC shunt, DC series and DC common. The DC common is again classified into two types. One is long shunt, the other one is short shunt, right? So now we will see the operation of DC shunt generator with the help of circuit diagram. So DC shunt generator, right? So here, let me, as I already told, here the DC shunt generator and DC series generator and DC common generator, these generators will be excited with the help of armature winding flux, and the DC separately excited generator will be excited with the help of some external means of exciter or by external DC current, right? Here the as a whole or as a common, DC shunt series and common will be excited, the coils of armature winding will be excited by itself, is known as self-excited DC generator, right? So I will draw the circuit for DC shunt generator. And this is the field winding. And this is the armature winding. Which is connected to the load. This is the load. Let it be a variable load, and the current through the load will be IL, and this point the current will be divided into 2, and this armature generator, armature current, armature conductors, this EG, the arrow mark indicates the voltage direction, and this is F, field winding polarity, so field winding terminals FFF. The current flowing here will be IF, and the current flowing here will be IL. IF or IS sketch, shunt field current, right? Okay, right. Now the armature winding will produce some flux. The armature winding will produce some flux due to residual magnetism. Residual magnetism is nothing but, by nature, whenever we wound a coil on a core, the particular setup will become a magnet, right? If it is acting as a magnet, or if while it is changed to the magnet, it will exhibit a magnetic property in terms of magnetic lines, flux lines, right? So with this principle, this armature conductors is placed on the armature slots, which will produce the flux lines, right, due to residual magnetism, and these flux lines will be very less, right, compared to the separately excited field winding, right? Because we have given external supply to the field winding to excite the field winding in separately excited DC generator. But here the armature winding itself creates some flux, which is known as residual flux, right? We are not going to give any kind of external supply to the armature winding, right? So by nature it is creating some flux. So that flux will cause the armature to create an extra energy with the help of prime mover. We will be connecting a prime mover to rotate this armature conductors or rotor of the armature, right? Right. So the rotor will be rotating and the conductors are placed on the armature conductors are placed on the rotor. Prime mover may be of motor or turbine, some external means. Now this is prime mover will be rotating, through which it is already having a residual flux. Now the rotation will produce more number of flux, and this will create some current, armature current. It is known as armature current. It will be flowing through the field winding. So now through armature current, IA current, or the flux produced in the armature conductor will produce the current IA, armature current, and this armature current is now flowing through the field winding or field coil, which will produce or which will excite this field coil, shunt field coil, right? Now this field coil will create some flux, main field flux or field flux. Now this field armature flux and field flux will link each other, where enormous amount of EG will be created, and force will be created, which will be named as energy or EMF. This EMF will be applied to the load, and the load current will be IL, right? So this is the basic concept behind DC shunt generator. And the field coil number of turns will be higher, and the resistance will be very less, or will be, because R is equal to rho L by A. If the length of the conductor increases, length of the conductor is directly proportional to resistance. Length of the conductor increases, resistance will be high, right? So where area of the conductor, the resistance will be very high in this shunt, right? Because by this relation, the area of the conductor will be very thin. And turns will be higher, right? So length will be higher. If length is higher, then resistance will be higher. Right? So in DC generator, thin coil with large number of turns will be placed in parallel with armature coil, right? So the setup is made to excite the field coil with the help of armature current, right? It should be connected in parallel. If we connect this number of turns coil in series with this armature conductor, then we will have a huge amount of current flowing through the conductor, which will make the motor to burn out, right? So now we'll see DC series generator with the help of circuit diagram. And this is the armature. A. And this is load. It is variable load. Let us assume a variable load. This is S1 and S2 series field winding. CAA, and the generator EMF will be EG, right? And the current will be IA here, right? So the current through this will be IL, and the current coming out of the field coil will be ISE, series field coil. So it is connected in series, the field coil is connected, so the current is represented in represented as ISE, right? So generator this DC series, this is the armature connector is placed in series with, or the armature connector is connected in series with field winding, so it is known as DC series generator. Now, due to residual magnetism, the armature connector will produce a flux which will produce some amount of voltage, and the voltage will create current IA, armature current. This will flow through the field winding, series field winding S1 and S2, and here the series field coil will be energized, and this corresponding field coil will produce some flux, and already there is some flux in armature winding. Both the flux will get linked each other, which will produce an extra amount of voltage, which is EMF, EG, which will flow through the load IE. Which will flow through the load, right? And the current drawn by the load is represented as IL, right? And the conductor size is very, very thick, in DC series generator, and the resistance is very, 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 very less in DC series generator, and the length also very, very less. The length of the conductor, number of turns, look at the number of turns here. Maximum the number of turns will be 1 or 2. So the length is very, very less, and due to this relation R is equal to L by A, the resistance of the conductor is very, very, very less. So the coil resistance will be very less. So a small amount of current is enough to excite this field winding. Small amount of current, small amount of armature current is enough to excite this field winding, right? So this is the principle behind DC series generator. So now it is clear. I think now it will be clear for you that the principle behind, or the operation of separately excited shunt generators, similarly under self DC shunt generator and DC series generator. These are the topics that we have seen with the help of the circuit diagram relations. Similarly, there is the one more type, which is compound generator. It is again classified into two types. One is long shunt, and one is short shunt, right? Here I'll just explain the operation of this long shunt, short shunt without circuit diagram, right? The long shunt and short shunt connections are somewhat different, right, compared to this DC series and DC shunt generator, right? DC compound generator is a combination of DC shunt and DC generator, where the long shunt will have two windings. As I already told, DC compound generator is a combination of DC shunt and DC series, right? So the DC compound generator will have two field windings. So one field winding will be connected in parallel, the another field winding will be connected in series with the armature winding, right? So we'll see the circuit diagram. For long shunt. And this is a field winding. The armature, and this is a load, variable load, and this is generator, armature, brush, A, S1, S2, F, right? And the current here will be IA sketch, and this IA and EG is the generator voltage. This is IL current. This will be IESC, series current, right? So now look at here, this long shunt DC compound generator, it has two field windings. Series field winding is connected in series with armature winding here, and this both is armature winding, series winding, field winding is connected in parallel with the main field winding, right? So there are two field windings. This is long shunt, and these are the corresponding current notations, whereas the short shunt will be of, this will be connected here, this corresponding field winding terminal will be connected. This terminal will be, let us assume that there is no terminal here. Now this is the ISH current. This is the setup or circuit diagram for short shunt DC compound generator, right? So I think that the topic which we have seen today is clear for